So today we are going to deal with the topic about power of. Okay. So what is I? I is nothing but an imaginary number, right? Okay. So can we discuss about the powers of I? Yes. So what is I power one? I power one is nothing but I. Right. I square. I square is minus one because the value of I is root of minus one. On taking square root on both sides, I will get the value as I square is equal to minus one. I power 3. So I power 3 I can as I power 2 into I power 1 because I'm applying the rule that is A power m plus n is equal to A power m into A power n. I will get the value as I square is minus 1 and I power 1 is I. So the product will be minus I. Okay, so I cube is minus I. I power 4 is nothing but I square into I square. So that is nothing but minus 1 into minus 1, that is nothing but 1. So I can find by this also. I power 3 and I power 1. So I power 3 into I power 1 means I power 3 is minus I power 1 is I. So on product, I will get the value as 1 because minus I square is minus 1. So minus into minus 1 will be plus 1. So now I get those values. That is nothing but I power 1 is I power square is minus 1. I cube is minus I power 4 is 1. So by using this, I'm going to find the higher powers of I. That is I power 5 when I find it, I will get the value as I. Because I power 5 I can rewrite as I power 4 into I power 1. So that is nothing but I power 4 is 1 into I power 1 is I. So product, we will get the value as I. So I power 6 when I find, I will get the value as minus 1 because I power 6 means I can take the product of I power 3, I power 2, I power 1. So when I take these three products, I will get the value as minus I into minus 1 into I. So minus into minus plus I square is nothing but minus 1. So I power 6 is minus 1. So I power 7, I will get the value as minus I. I power 8, I will get the value as 1. Okay, so these are the these are the 4 unique values that's going to repeat again and again. That is I, minus 1, minus I, and minus 1. So these are the 4 unique values that is going to repeat again and again. Okay, so when I find for I power 9, I will get a value as same value as I, which I got for I power 1 and I power 5. And when I write for I power 10, I will get a value as minus 1. For 11, that is nothing but minus I power 14, sorry, I power 12, that is nothing but 1. Okay. So then for I power 13. 13 is I power 14 is minus 1, I power 15 is minus I power 16 is plus 1. So now I'm going to collect the number which is in power. Okay. So see here, for those values, I got I. For those values which I got I, I'm going to collect those powers first of all. Okay. So see here, for 5 I got I. The answer is I. And for 9, I got the answer as I. And for 13, I got the answer as I. So when I collect these numbers, 5, 9, 13. So these three numbers, when I divide it by 4, I will get the remainder as 1. And now I'm collecting the value 6, 10, 14. These are the three numbers. I'm getting the same value as minus 1. Okay. For their powers of I. I'm getting the value as minus 1. So that is nothing but 6, 10, and 14. So these three numbers, when I divide it by 4, I will get the remainder as 2. Okay. So next, for 7, 11, and 15. So 7, 11, and 15. When I divide it by 4, I will get the remainder as 3. And for these three numbers, I am getting the same value as minus 8. Okay. And for 8, 12, 16, remainder is 0. Okay. So why I am dividing particularly by 4? Because after 4 numbers, the process is going on repeating, right? So I'm dividing these digits by 4. So these are the 3 digits. When I divide it by 4, I will get the remainder as 1. These are the 3 digits. When I divide it by 4, I will get the remainder as 2. So these are the 3 digits. When I divide it by 4, I will get the remainder as 3. And these are the 3 digits. I will get remainder 0. So this is the point to be noted. So, okay. What I'm conclude to say means the powers, when I divide it by 4, if I get the remainder as 1, my answer will be I. And the powers, when I divide it by 4, if I get the remainder as 2, means I will get the answer as minus 1. The powers, when I divide it by 4, I get the remainder as 3, means my answer will be minus I. And at last, my answer will be 1. Okay. So by using this, we can find any higher power of I, right? So for example, now I try to find the power of I power 1000. So 1000, I'm dividing it by 4. So I'm getting the remainder as 0, right? So here remainder is 0. So remainder is 0 means my answer will be 1. So please note it down. You need to check with the remainder, not the quotient. Okay. So I power 1000 will be 1. For example, similarly, if I take I power 2958. So 2958, when I divide it by 4, so I'm getting the remainder as 2. So remainder as 2 means my value will be minus 1. So that is nothing but I power 2958 will be plus 1. So it's really easy, no, to find the higher powers of I. Yes, that's fine. Quite interesting. Right. Okay. So now I'm going to deal with the negative power. Negative power is not that much difficult. For example, if I take I power minus 5. Okay, that is nothing but we need to rewrite this as I power 1 by I power 5. Because we know the positive power of I. No? So I'm rewriting this I power minus 5 as 1 by I power 5. So 1 by I power 5 is nothing but 5. So 1 by I, we need to find the value by taking conjugate. Okay, so by taking the conjugate and on multiplying the, the conjugate on both the numerator as well as denominator, I will get as minus I divided by minus I square. That is nothing but minus I divided by minus of I square is nothing but minus 1. Minus of minus 1 will be plus 1. It is nothing but minus 1. The value will be I power minus 5 as minus I. So while it comes the negative power of I, we need to rewrite this as in terms of positive power of I by moving the term to the denominator and taking the conjugate of the denominator, we can finally conclude the value. So that's it. Thank you so much.